All right, everybody. Rachel here, CIT 260. This is our individual final. So I'm going to talk a little bit about what we learned, which was so much. The first thing that I want to talk about is static class variables versus non-static class variables. So you can use a static class variable anywhere within a class. So if I declare my public static int bioland right here, I can actually use it anywhere in the class. So if I have a different function, I can use it in that function. If I don't actually in Byland, but I could. I can use it anywhere in that class. A non-static variable can only be used in the function in which it's called. So I created this public static create map. I can only use these max row equals 5 max column in this function unless I created a different variable. So if I were to go into map control, create another function, I could create another variable to hold those same integers, but it would have to be a different variable because it's a non-static variable. So arrays, there's three types of arrays. First, I'm going to talk about just a regular array. Arrays are objects and they can be used to reference their length. They can be used as a static and they must be an integer. They can't be used as a long or a short variable. So this is another picture of that map control, which is where we used our arrays is in our map. We did use just a regular array, although we could have used a different one. We declared our array, put our max row and max column, so it's a 5 by 5, and we actually did reference their length. So when we, this is kind of hard to see, but when we're looking for the map location, we reference it and say 0, 1. Okay, that's one of the locations on our map. An array list can actually be added to or changed. That's the biggest difference between the two. So in this example, they declared their array and then they added a bunch of elements to that array. And then they actually deleted a few. And then they can print what the size is. They can print everything. They can delete things and then print it again. So an array list we actually didn't use in our program because there was honestly no reason to add and take away stuff like that from an array. So this is just an example that I found. All right, a unum, they're fixed and you must know all of the values at the time of compilation. So, for instance, we've got a car. This is just an example I found again. And we know all of those 5 values of that unum. So when the program is compiled, we know exactly that that all of our values are Lamborghini, BMW, Audi, Fiat, Honda, all of those. We know that as soon as the program compiles. And so that's when you use an unum. We could have actually used a unum when we got our get inputs. However, we did not. We used just a regular case statement, but it would have made sense to actually declare a unum and then go through and say, okay, enter number 1 to learn more about wheat, number 2 to learn more about tithing, etc. And we could have used a unum for that. Our map control is actually where we used, like I said, we talked about those arrays and we did reference those lengths. So 0, 1, and at that location there is a potato, and then they have a question and all of that. So we referenced each individual location with a question, which is actually how they win or lose the game, is by their points and their questions. So throwing and catching runtime errors. Um, in order to throw and catch their runtime errors. So first of all, the difference between a compilation error and a runtime error is when you compile and there's an error, you have to fix that error because you can see it immediately. But this is catching anything that you don't necessarily see immediately. This is like, so if the user enters the less than 0%, you can't have less than 0%. So we're going to throw and catch this error because if we don't, then it's going to create problems as the program's running, hence runtime errors. This is stuff that happens as you go through the program. So same thing with percent is greater than 100. You can't have greater than 100%. So we do this actually a lot throughout the whole program. Let me pull it up really quick. There's a lot of different inputs that we need to catch exceptions. For instance, bioland, game control, harvest time, map control, population. We had to catch all of those errors because we didn't want there to be problems as they iterated through the game. So in this one, we did a throw new exception. Tithing can't be negative. And there's a lot of exceptions like that. All right, so a byte stream is a 8-bit system. It uses file input and output streams. The biggest difference is you can actually use a byte stream for anything, but it's not very useful when you're inputting in text files because it's literally going to do it one letter at a time because byte stream. So it can't really do large files, or it can, but it's not very applicable for large files because it's not going to work as well as using a character stream. So a character stream is a 16-bit Unicode input and output, and it uses file reader and file writer. So this is going to be really good for those bigger text files like that have paragraphs of information because it's going to read that a lot easier and a lot faster. And this is an example of a character stream. We actually used a byte stream when we coded ours, and it is right here. So we are just reading in files. So this is basically just reading in a file and saying like, okay, they're starting in a game, let's read in this file, or they're saving their game, let's read in that file that they saved. Stuff like that. That's basically what all of this is saying. It has that in file, so if it doesn't equal null, we're going to close it. If it doesn't, if the out file doesn't equal null, we're going to close it. So that's what we did for our input and output. Our game works like this. Oh, let's start a new game really quick. The way that it works, I kind of said it earlier, but it works on a point system. So when you are moving around on the map, I'm going to start a new game. And let's go ahead and look at the map really quick. So I'm going to hit 7 to display the map. So when you're moving around on the game, you are going to be asked a question every new place that you're at. So these asterisks say this is where you're at in the game. So we are at inventory 1, okay? Anytime that you move around on the game, it's going to ask you a question. And then you're going to get points based on whether or not you get the question right. So let's go ahead and move around our player. So I'm going to move my player down. So now we know that we're in inventory 2. It's actually going to ask us a question. And if we get that question right, we'll get 5 points. If we get that question wrong, we won't get any points. For each question that you get right, it's going to be added to your total points. And at the end of your 10 years, if you have enough points, you'll win the game. And if you don't have enough points, you'll actually lose the game, because that's how we did the game, which I really like. It kept it really simple as far as being able to iterate through things. The years iterate through every 3 places they stop at. It's going to pop up like, okay, you've entered a new year. And that's kind of how we decided to make things go. Just to make it easy to follow, easy to win and lose, stuff like that. So that's kind of what I learned in CIT 260. Thanks so much for watching.